Mouse eugenics, humiliation, shock therapy. Today, we're going to be covering a bunch of interesting methods used to create animal models for depression. Let's talk about animal testing. It's a crucial part of moving medical research forward and helping improve human health. Yes, there are ethical concerns we need to think about, but animal models give us insights into complex biological processes that we just can't study any other way. These models work so well because animals and humans share a lot of the same biological traits, making them great test subjects. When it comes to physical health issues, testing is pretty straightforward. We can measure things like changes in genes, antibodies, and protein levels. All stuff scientists can put into neat statistics to show if a treatment is working. But here's where it gets tricky. Studying psychological conditions like depression in animals is much more challenging. Mental health is complex, so researchers have to get creative with behavioral tests and observational methods to see if animals show signs similar to that of human depression. It takes careful planning and lots of checking to make sure these tests actually reflect what we see in humans. That being said, some of the stuff scientists end up doing to animals just feels wrong. It is important to remember that we are not discussing the methods of testing efficacy of a medicine on treatment of depressive/anxious disorders, but rather the means to create and determine these tendencies in an animal model. While symptoms like guilt, suicidality, and a sad mood are almost exclusively human features of depression, there are many measurable traits that scientists look towards when evaluating animals. The most commonly looked at traits include helplessness, or a feeling of inability to change a situation, anhedonia, or an inability to enjoy activities that were previously enjoyable, and behavioral despair, a state of immobility reflecting a lowered mood. There are many more traits that scientists study, such as changes in appetite and sleep, but this provides a general overview. The validity of an animal depression model is evaluated through three essential criteria: face validity, or how similar the viewed symptoms are to human depression; construct validity, how similar the causes of the symptoms are to human depression; and pharmacological validity, whether existing antidepressants can reverse the present symptoms. These guidelines provide scientists with a framework to determine whether an animal is truly depressed. With that in mind, let's examine the shocking techniques that scientists use to create depressed animals, some of which even put the CIA to shame. Acute stress models involve applying severe physical stress to animals. Scientists originally used two main tests to create depression-like states in mice. The first one is the forced swim test. In this test, researchers place a mouse or rat in a water cylinder it cannot escape from. After trying to swim for a while, the animal gives up and just floats, showing behavioral despair. The second test, the tail suspension test, works similarly. Scientists hang a mouse by its tail in a container. Like in the swim test, the animal eventually stops trying to escape. Scientists initially believed that inducing behavioral despair was sufficient for testing antidepressants. However, this approach fell out of favor because the depression was short-lived and responded too readily to various substances, including drugs like ketamine that aren't conventional depression treatments. A better model is the learned helplessness model. It uses unavoidable stress, usually in the form of electric shocks, until the animal shows signs of giving up. The animal gets breaks between repeated exposures to the shock chamber. Later, it's put in a new chamber where escape is possible. If the animal doesn't try to escape even when it can, scientists consider it depressed. While this test works better, it fails to produce depressed rats anywhere from 10 to 80% of the time. To improve success rates, scientists have now started using reverse eugenics with rats that give up easily. This creates what they call congenital learned helplessness models. These rats exhibit depressive behavior from birth, and their brain changes mirror those found in humans with severe depression. The model is so effective that these rats will often fail to escape the second chamber without any prior exposure to the inescapable shock chamber. It's important to note that latrogenic/secondary depression models exist. These are depression symptoms induced through medical means, such as gene editing or physical illness. Depression that develops secondary to medical conditions, like from strokes or pancreatic cancer, is clinically indistinguishable from primary depression. Next, let's examine chronic stress models, which rely on long-term, uncontrollable, and unpredictable stress. The first notable example is unpredictable chronic mild stress. This model subjects rodents to various stressors over several weeks, included but not limited to food and water deprivation, overnight illumination, and cage tilt. These models show high face and pharmacological validity, as both the symptoms and responses to treatment closely mirror that of human depression. Early stress models follow a similar principle, but focus on postnatal pups, primarily through maternal separation. Interestingly, acute early life stress was found to reduce anxiety in later life, with depression-like behaviors only emerging under sustained stress conditions. The chronic restraint stress model takes a more focused approach, using a single consistent stressor. Mice are restrained for a minimum of 2 hours per day for 14 to 21 days. While this produces similar results to the unpredictable chronic mild stress model, it falls short in terms of construct validity. Perhaps the most intriguing approach is the social defeat model. While this model meets all three validity criteria, it can only be studied in certain male rodents, making it both expensive and limited in scope. In this model, researchers select smaller, more submissive male rodents and expose them to a series of encounters with older, larger, and more aggressive males. Eventually, the test subject will be attacked, at which point it experiences humiliation and defeat before being moved to face another dominant male. This process eventually leads to anhedonia and various physiological changes consistent with severe depression, including decreased sexual behavior, increased defensive behavior, increased anxiety, decreased locomotor and exploratory activity, changes in circadian rhythmicity, alterations in feeding and body weight, sleep disturbances, and impaired immune functions. I want to emphasize that animal testing plays a vital role in medical development. This video isn't meant to criticize that fact. The European Animal Research Association has shown just how many human lives have been saved through this research. It's fascinating, though, to see what science can achieve. The fact that we can now reliably create lasting depression in other creatures is both remarkable and scary. Making this video gave me some real insights into depression and its environmental triggers. The social defeat model really highlights just how impactful experiences like bullying can be. One interesting aspect was seeing how researchers can quantify depression and anxiety through behavioral tests, turning these usually abstract concepts into measurable data. I love researching these interesting topics and sharing what I learned with you all. If you found this interesting, please like, comment, and subscribe for more content like this. All sources are linked in the description below. Thanks for watching.